Okay, can I get started, please? Okay. Oh, thank you. So what I want to do is actually start out by doing these two problems. Actually, I won't do them. You will do them. Let's go write this down. Okay. So what I want you to do is I want you to find y prime and y prime for both of these. For the second one, you will have to do something before you can start getting the derivative of the function, okay? You'll have to get something before you do the derivative. So I'll pause here and have you guys work on this, okay? Work on this. Anybody have questions? Can you factor the bottom one out? Anybody have questions for good take on this? No. So the second one, you've got to FOIL and then differentiate. Okay? Right, so everybody got this as 2x. And then this guy became 2x plus 1. Okay? Now, what's the connection between these two guys? Okay, let's explore the connection between these two guys, okay? So if you think about this, you can pretend that this is like an x squared. Is everybody with me on that? Pretend that it's like an x squared. So if you were to differentiate this, you would go 2, and then you'll have an x, but instead of an x, you will have, and then you'll reduce the 2 by 1. See how that came right there? Well, you have to, because what are you going to do? See, the rule is, gets a little complicated if I make this an x cubed. Okay, then we're going to do something else. Then we're going to do something else. Because it was an x, it was very obvious as to what you needed to do. Okay, you guys need to pay attention here. Okay? If it's not, then I'm giving you rules, okay? And that's the chain rule. Okay, that's the chain rule. Okay, so I'm going to do this one instead of, even though it says you do, I will do it so you guys get an idea as to, Monica, you really want to put the camera away and focus. Yeah, focus here, another camera. The math. Okay, the math. No, I should. Okay, stop brown nosing here, Laura. You did really well yesterday. Shh. You did well yesterday, and then you got all panicked and bitching and crying and.
I wasn't bitching and crying. I just
yeah, you was. No, but before that, I don't know. It's gonna be as hard as the day. Oh my God! Sorry.
I was like, I don't understand what I'm doing. Help me for. Then we did it together, and I was like, oh my God, I see the
so
light.
Easy. Okay. All right. So. In order to do this, one of the techniques that I'll teach you is called U substitution, and this is the reason why you do that, okay? It may be this example may be too simple actually for the U substitution, but let's go ahead and do that, okay? What I'm going to do is I'm going to say let U is equal to 2x minus 1, okay? So then y becomes U squared. Is everybody with me on that? Okay? Now notice that what I do want is I want dy by dx. That's my goal because y is a function of x, as you can see. But it's a composite function of x and it gets a little complicated, although it may not be complicated in this example. Okay. So what I will do instead is I'll differentiate y with respect to u first because y is a function of u right here. You guys with me on that? And then I'm going to times it by du by dx, or chain it, okay? That's where the chain rule comes from. That's the terminology, the chain rule. And the way you can think about this is that it makes sense because if you are to kind of pretend to cancel this out, pretend to cancel that out, then on the right-hand side you get dy by dx. On the left-hand side you get dy by dx. So this looks like a good idea. It looks like a good idea. Well, let's go through it. Okay, let's go through it. So let's work this out. So can someone tell me what's dy by du then? 2u. Is everybody with Henry on that? Differentiate this with respect to u. Using the power rule. Okay? And then you're going to take du, which is this guy here. You'll differentiate that with respect to x. What do you get? 2. So you get 4u, is that right? But u is your variable, so you need to replace it with, hang on, let me finish this. You need to replace it with 2x minus 1. This is your final answer. Okay? So this is doing the u substitution method. Okay? This is doing the u substitution method. Is everybody caught up on this? You guys have questions on this? Laura?
Why did you multiply 2u times 2 instead of divide?
No, it's a multiplication right here. It's a product rule, right? There's a multiplication right there. This is a multiplication here.
Why did you did it the derivative u? And you canceled out the u.
No, I'm not. Again, you're not paying attention. I'm canceling out only to pretend that it's canceled out. Because if I kind of pretend that this is canceling out, then I get a dy by dx on the right hand side, don't I? Don't I get this? Isn't that what I want? So then it looks pretty good that if I do dy by du and times it by du by dx, then it makes sense. It looks like a good idea. Let's do some examples and then you'll see that. Some more examples. Yeah, we're going to do that in a minute. Cindy.
How come u is only 2x minus 1 2x minus 1 squared?
Because what's the point of making it squared? Because then you still have to differentiate that using a power rule. Yeah, you'll see in a minute where the connection's coming from. S.
Where'd you get the 4u from?
2u times 2. 2 times 2 is 4.
Oh.
Okay, let me go over this one more time. Okay, you guys really need to focus on this. Really, really need to focus. Because this is really an important rule. Extremely important rule, okay? Do you want me to erase the whole thing and start over again? Or you guys can see what's going on?
Everything up to the point where you can tweet like this.
Okay, you know what? Let me erase all this stuff. So, let's forget trying to justify why this rule works. The rule is that you're going to dy by du times du by dx. That's what you're going to do. Okay? I try to justify the rule. If you get it, that's good. If you don't, it's all right. Okay? You're going to do that. All right? So, y is a function of u, as you can see from here. As you can see from here. Y is a function of u. How would you differentiate y with respect to u? What would you get? 2u, right? Using the power rule. And then you're going to multiply it by du by dx because u is a function of x right here. Right there. So what do you get when you differentiate u with respect to x? 2. What's 2 times 2? 4. Except you don't want u because u is an intermediate variable. It's something you introduced, so you go to undo it, and you undo it by taking the definition of u and plugging it in place of u.
Why aren't you like what is the derivative of y over the derivative of u? Why aren't you dividing it by the derivative of u?
This is not a division you are doing. So supposing if y was x squared, Laura, let me ask you this question. What's the derivative? What's the derivative? So instead of x, it's u.
No, I don't understand why you have dy over du times du over dx, but when you're putting it out there, you're only giving us the derivative of y and the derivative of u. You're not.
No, you can't say derivative of y and derivative of u. That doesn't make sense. Derivative of y with respect to u. With respect to u. In other words, you're using u as the independent variable that you're differentiating with. Okay, there's no concept like derivative of y, derivative of u. They're not two separate derivatives. This thing is one entity. It's one entity. Just as y prime is dy by dx. Right? Y prime is dy by dx. Okay, let's apply some more rules and then you'll see that. Okay, so this was using the chain rule. Okay, so it's using the chain rule through a u substitution. Let's take a look at it doing it the faster, easier way. Okay, so what you're going to do is you're going to differentiate this as if this was like an x squared, as if it was an x squared. So you're going to bring the 2 down. You guys with me? Except that instead of x, it is 2x minus 1. And you're going to reduce the 2 by 1. And you're going to times it by the derivative of whatever is inside. 2. Okay? So simple method, long ass method. Take your pick. Yes? Any composite function. Any composite function. And we'll do a few today, okay? And then tomorrow I guess is Brenda day, so we're not going to do any work. You guys are hopefully going to be sleeping and not noisy. Okay? Did we do that last year too? To get the day off? Okay. Well, Cindy, for you it'll be a real hangover, man. You better watch it, girl.
What?
Yeah, Cindy. Yes. Sorry? Friday's work's going to be on Friday. Okay, everybody get the kind of informal way of doing this? We'll see some more examples and you'll see, okay? All right, here is the formal definition of this. Okay, here's a formal chain rule definition. You're going to bring it down. And in parentheses, what are you going to put? Which is what? Whatever's inside that parenthesis, you can see that. X cubed plus 2. And then you're going to times it by the derivative of what's inside. Nice, 3x squared. This becomes... Yes, you do. My bad. Thank you. Good job, Tatiana. Yep. 4 times 3. So you want to put that in the front. Is everybody with me on this? Yeah? No, 4 minus 1, right? The power rule. Okay, 4 minus 1. Is everybody okay on this? Okay, so using the power rule, this 4 comes down here, right? You reduce this by 1, right?
Yeah.
That's right there. The inside stuff is the inside stuff right there. Then you times it by the derivative of the inside. Derivative of inside is 3x squared. The next step is 4 times 3. 12. 12x squared. Remember, these are all timesing, okay? We are timesing this stuff. No, it's 4 times this 3. Okay? Is everybody with me on this? Okay, here's an example for you to try your hand at, okay? Okay, people, Laura, focus, Cindy, focus. Okay? What are you going to do first before you start differentiating? Hang on, Stephanie, let's get other people in here. Hang on, Henry. How about the boy side of the room? Yeah, Ed. Yes. Fantastic. Good job. Good job. Okay, guys, do it. Well, the other way would be to binomial this and then differentiate. Can you imagine that? That's the reason why the chain rule is so powerful. It's extremely powerful. I don't know why they call it the chain rule. They should call it the unchained rule because it unchains you from misery.
Yeah, really.
Okay, so Laura, you're up there.
Okay, can you put on my paper first?
Yeah.
Be there from 9 to 4.
Don't worry. I know, I'm in my car.
So, do you know approximately when the